essential to be able to solve problems with redox reactions is to actually learn how to balance redox reactions correctly. Balancing redox reactions is one of the most challenging balancing exercises that you can actually have. So let's see if we can learn how to do this well. There are various methods to balance redox reactions. The one that we're going to explain here is called the half-reaction method. Another common balancing method is called the oxidation number method, but we're not going to study that. Instead, we're going to solely focus on the half-reaction method. All right, so there's various steps in balancing redox reactions with the half-reaction method. Okay, the first one is to split the reaction into the oxidation and the reduction. All right, so we're going to identify what species oxidizes, what species reduces, and we're going to treat them separately. This is why this is called the half-reaction method. Okay. Now, for each one of the half-reactions that we're going to have, you have to balance the non-oxygen, non-hydrogen atoms first. Non-O or H first. That's the first step that you have to do. For example, if you have iron or carbon or any non-hydrogen or oxygen atoms, you balance those first. Okay. Then you balance oxygen with water. Okay, so if you have two atoms of oxygen in reagents and atoms of oxygen in products, you would add two water molecules to products in order to be able to have the same oxygen ingredients and products. Okay, after that, what you do is you balance hydrogen atoms with protons. Okay, so much as before. What you actually do is look at the balance of protons of hydrogens in the reagents and products, and then you add protons to the reagents and products so that you have the same number to both sides of the reaction. Okay. Now, point number 5 is to balance the charge with electrons. Right, and this will be self-evident as we run a couple of examples in this video. And finally, what you do is you balance both half-reactions. Okay, so you multiply both half-reactions by coefficients so that the electrons cancel between the two half-reactions. Okay, so balance half-reactions. So that the electrons cancel. Alright, so let's see how we actually apply these rules to a fairly simple reaction to start with. Okay, and the reaction that we're going to work with to start with is copper with silver plus to generate copper 2 plus silver. Okay, I'm not writing here the physical states of those species because we're not interested in that. We're just interested in using this reaction as a way to start balancing redox reactions. Right, so let's identify the two half-reactions. Okay, we see that copper goes from an oxidation number of 0 to an oxidation number of +2. So that is the oxidation half-reaction. Okay, I'm going to write it here. The oxidation half-reaction is this. Copper 2, copper 2 plus. All right, and then we see that silver goes from a +1 oxidation number to a 0 oxidation number. All right, so there is a reduction. So the other half reaction is the reduction. Is going to be silver plus 2 silver. Alright, so then let's use this list of rules that we have right here to balance these half reactions. Alright, we have already split the two half reactions, then balance non-oxygen or hydrogen atoms first. I have 1 atom of copper, 1 atom of copper, balanced. 1 atom of silver, 1 atom of silver, balanced. Okay, we've already done this. There's no oxygen, there's no hydrogen, so we're going pretty fast. Now we have to balance the charge with electrons. Alright, so how do we do this? Here, you have a +2 charge in products, no charge in reagents. So to balance that off, you have to add here 2 electrons. Now you have 2 negative charges, with two positive charges, there's no charge there, there's no charge here, we're good to go. Okay, that is how you use electrons to balance the charge. Okay, for this other reaction, we have now that you have a charge of +1 right there, a charge of 0 there. So if we add here 1 electron, then the charge is balanced in this half reaction, in the reduction half reaction. Okay. All right, so we're in step 5. Let's go to step 6. What we actually have to do now is see if the electrons in between these two half reactions balance each other. Notice that here I have 2 electrons in products, and here I have 1 electron in reagents. Those electrons would balance each other if I multiply all of this half reaction by 2. Okay, in that case, I'm actually going to have that the electrons will cancel. Okay, so there is actually going to be the end. I tally all of this up to find that this reaction is balanced by the following coefficients, right? So in the first one, I don't have to do anything. In the bottom one, I have to multiply everything by 2. So that would be 2 silver plus 2 silver. Okay, we can check that this we have balanced this reaction well. We can check the atoms, copper and copper, no problem. We can change, see that silver and silver, 2 silver with 2 silver, no problem there. And then the charge has to be balanced as well. I have 2 plus in reagents, 2 plus in products. This reaction is balanced. Okay, so this is a simple example for how to balance a redox reaction with the half reaction method. What we're actually going to do now is use a more complicated reaction to see how the rest of these rules play out. Okay, I'm going to have to erase them though, so we'll keep them, we'll commit them to memory in order to be able to balance this more challenging reaction. All right, and the reaction is going to be permanganate, okay, with reacting with iron 2 to generate iron 3 and manganese 2 plus. All right, first we'll have to identify what oxidizes and what reduces to be able to write the half reactions. Okay, manganese has an oxidation number of +7. In permanganate, oxygen is -2, iron has a +2, here has +3, and then manganese +2. All right, so clearly this is an oxidation, and then manganese to manganese 2 plus, that is the reduction. All right, so let's write those half reactions. The oxidation and the reduction. All right, the oxidation is iron 2 plus to generate iron 3 plus. All right, the atoms are balanced. There's no oxygen or no hydrogen, so we don't have to worry about this. We just have to balance the charge by adding here 1 electron. Okay, so that half reaction is balanced. Let's go to the reduction then. MnO4 permanganate to generate manganese 2 plus. All right, the manganese atoms are balanced, but here I have oxygen in reagents and no oxygen in product. So here's when I use water to balance the oxygen atoms, right? I need to add 4 molecules of water to balance those 4 oxygen atoms that I have right here. Now I have to introduce hydrogen atoms so I can balance those using protons. Okay, here I have 8 hydrogen atoms, here I don't have any. So I add here 8 protons. And now I have that manganese, oxygen, and protons, all those, or hydrogens, all those are balanced. Okay, so the last step then is to balance the charge. All right, so let's see. Notice that here I have 8 positive charges, a negative charge, so I have here a +7 in reagents, and in products I have a +2. All right, so to reconcile this, I have to add 5 electrons to reagents. +5 electrons. All right, so now I will have +2 in reagents and +2 in products, so that charge is balanced. Great. I now have balanced both half reactions, and the last step is to make sure that the electrons cancel when I add up those half reactions. Okay, notice that in the bottom half reaction, the reduction, I have 5 electrons in reagents, and in the oxidation reaction, the top reaction, I have only 1 electron in product. Okay, so the way to solve this is to multiply everything by 5, everything in the top by 5. Okay, so I have here a 5, I have there a 5, and then I can put here a 5. Okay, and if I do this, then the reaction will be balanced. Okay, so let's see how that works by adding everything up. Okay, so the reaction is going to be permanganate plus 8 protons. The electrons cancel, so we'll have to write them out. Okay, plus 5 iron 2 ions to generate 5 iron 3 ions plus manganese 2 plus 4 waters. And again, we can always check to make sure that everything is correct. Manganese, I have 1 atom and 1 atom. Oxygen, I have 4 and then 4. Hydrogen, 8 and 8. And iron, I have 5 and 5. So atoms, this is all well balanced. What about charges? Okay, so I have here 8 and 10, 18 positive, with 1 negative I have 17 plus. There is a charge in reagents. And in products I have 5 by 3, that's 15, and 2, 17 plus. So that reaction is also well balanced by the charge. Okay? So this has been a description of how to balance chemical reactions with the half-reaction method, and we have applied that half-reaction method to balance two simple chemical reactions.